Hello, I'm Rachna and here I am with my Team 3 group project called Patent Recommendation System. So why have we come up with this idea is very simple but very deep. While personally going through patent recommendations and patent filing process, we have come up with very strong issues which a user could face, such as while searching for a patent, you need to particularly search for a keyword so that your patent matches with some other patents already being filed and you get good recommendations out of it. But there are multiple systems which could not recommend efficiently, so we thought of building our own recommendation system for patents which a user can use efficiently. For this, we have followed three different approaches just to compare the performance of each of the approach and then finalize on which module are we going to suffice for. So first approach which we followed is user-based collaborative recommendation system. And this works in three different modules called exploratory data analysis, rank-based system, and user-based collaborative filtering. So the flow of the system being, first is it tries to find out the unique number of patents and unique patent IDs and remove the duplicate patents so that redundancy is removed. And then it ranks patents according to how multiple times it has been read by different users. And then finally, user-based collaborative filtering, a matrix is being generated in which user IDs and patent IDs are formulated in terms of rows and columns, and the dot products of continuous users are being calculated so that we get to know which two users have similarity between them in reading those patents, so that the patents can be recommended to new users based on his interest, which are similar to previous users. Although the output of the system looks good, but the major problem which we faced while using user-based collaborative system is that although we have web scraped the data from USPTO website, it being approximately 15,000 different patents, but while using user-based collaborative recommendation system, you need to formulate the data set in terms of a particular user reading multiple patents and a particular patent being read by multiple users. By formulating this data set, you have to do this manually, and so the data set reduces to a very small size, which eventually and gradually reduces the performance of user-based collaborative system. So we thought of approaching towards the second strategy, which will be discussed by Ruchika.
Hi, I'm Ruchika Hazarewal. Now I'm going to discuss about the improved solution, as Rachna has already talked about the drawbacks of user-based collaborative filtering. So this is our system architecture. First, we have three phases: data engineering, data analysis, and product prototype. So in data engineering phase, we are getting data from USPTO, and we are using Python to get the patent details. After that, we apply data cleaning, data selection, feature engineering to the data, and fed the output to the data analysis phase. And in this phase, first, we analyze the data, which features to analyze to get the best similar products, and after that we fed this to a recommendation system. Here we have applied two recommendation system that we are going to discuss later, and this output is fed to the processing. Here we have three fields: input field, first a user ID, patent ID, keyword, and after this input we get output on our website, and this website has been deployed on AWS EC2. Going to talk about data acquisition process. Here you can see the base URL, and we have appended our search string to that, and we are using Beautiful Soap as HTML parser. So we have a loop which runs until it reaches the result limit, and this is the main function which gets the patent details, get patents from results URL. And after this, we have data preprocess step. Here we remove the redundant data. First of all, some of the patents are getting repeated in our search. After that, we remove the missing value. Somehow some patents don't have abstract title or authors. We either substitute those values or remove them altogether. After that, we selected the attributes that will be needed for our feature engineering. So in step stemming, first we have taken all the abstract of the patents, then we have removed the punctuations and removed the English top words. After that, we have performed stemming, and this all data has been fed to the abstract org field. So here is the data set, which looks like now. So this is patent number, this is abstract, classifiers, file date, URL. Now the function flow will be discussed by Prachi.
Thanks, Ritika. Hi guys, I'm Prachi and I'll be talking about the functional flow of our patent recommendation system. As you can see from the diagram, for a patent search, we have provided three options to the user: keyword search, patent ID search, and user ID search. I'll be talking about the first two options here, keyword and patent ID, which basically form the basis of content-based recommendation system. So the idea here is to match the user provided input against all the patents present in our data set and then recommend patents to the user. So when a user provides a keyword, we first convert it into a TF-IDF vector and match it against all the TF-IDF vectors of the patents present in our dataset. If a user provides a patent ID, we first fetch the abstract of that patent ID, convert it into a TF-IDF vector, and then again match it with all the TF-IDF vectors of the patents present in our dataset. Once we have these TF-IDF vectors, we then feed it to the KNN model and recommend patents to the user sorted in descending order of their distance from the user provided input. So here's a step-by-step process of what happens in the content-based recommendation system. Step 1 is to generate the TF-IDF vectors and dump it in a pickle file. So this is one of the pre-processing steps that happens before the user is using our system. We fetch the abstract of all the patents, convert it into a lower case, split all the words, remove unwanted characters, stop words, perform stemming, then generate the TF-IDF vectors and dump it into a pickle file. The reason why we're doing this pre-processing step is to improve the time efficiency of the system so that user does not have to wait for seconds and even minutes sometimes if the data set is huge enough. Now step 2 here is fetch the keyword in patent ID and generate the fit transform vectors. This is again another pre-processing step to improve the time. The step 3 here is feeding all these TF-IDF vectors to KNN model and send the data frame as a response with the required fields. So this step happens at runtime when a user is providing a keyword or patent ID. We convert that abstract of the user provided input into TF-IDF vectors by first removing the unwanted characters, stemming, the same process that we perform on all the abstracts of the patents. So once we have the TF-IDF vector, we then feed it to the KNN model nearest neighbors with n neighbors as 5. This KNN model then sends us a response of all the distance and indices of these neighbors. We then convert this response into a data frame and send it back to the Flask applications, which displays the output to the user in a sorted order of distance. So as an example, this is what a KNN plot looks like for a particular patent sorted by the distance. These are all the patents similar to a user provided patent along with their distance. So that's it from content-based recommendation. Pavni will now explain item-based collaborative filtering.
In the second half of the project, we used hybrid recommendation system to get the recommended patents when the user ID is given. So what we did in hybrid recommendation system. So we have calculated TF-ID of vectors for the abstract of all the presents that are present in our data. And we have calculated cosine similarity for those TF-ID of vectors. So we are also used like item-based approach. So it is item-based collaborative filtering is mainly based on the similarity between the patents. So it basically looks for the patents read by a particular user and try to fetch the patents which have the highest similarity value with the patents read by the user and try to recommend those. Coming to the data part, so we have created data such that each user can have multiple, like 2 or 3 patents under his account. So if we go step by step code implementation part, so for initial step, as we discussed, we have created a TF-ID of vector. So for all the abstract words that are present in the patents, and before that we did like couple of things, like we did stemming, and we have tried to delete cache stopped words, and we have created a cosine similarity matrix. So this is how our cosine similarity matrix looked like. So for all the patents we have. So in the next step, we try to check if the user ID is or what we have in in our data is, it checks for the user ID that is there in our database. If the user ID exists, it try to fetch the patents that are read by that particular user. So later from the similarity, with the help of similarity matrix, it tries to get the patents which has a high similarity value. Even after getting the patent number, it will try to fetch other details like patent number, abstract, the similarity value, title, and URL, and try to populate those on the application UI. So other than that, what we are doing is the patents that are read by the user are also populated on the UI with the help of this function.
Hi guys, this is Prachi again. So let's check out the demo of the patent recommender system. This application is currently deployed on Amazon Cloud as an AWS EC2 instance. So yeah, let's start. So as we discussed earlier, we've provided these 3 options to the user: keyword, user ID, and patent ID. We've also provided some keyword suggestions because these are all the keywords that are present in our data set. So let's check out the patent recommendation if I provide a keyword as cache. So yeah, this is fast because of the pre-processing steps and creating the TF-IDF vectors and dumping your pickle file in advance, as we discussed earlier. So these are the similar patents, and as you can see, it provides relevant patents based on these distances in a descending order. So this one is the closest patent that it found with cache. As you can see, it has all the patents have cache keyword in them. If I click on one of the patents, it redirects me to the USPTO website from where we scrape these patents, and the user can read the whole patent instead of just going through the abstract here. We can try with another keyword, which is cloud. So yeah, it shows cloud, these distances. So this one is the closest patent. I can look for the patent on the USPTO website. So yeah, let's look for another option here, which is patent ID. I can provide any patent ID. It first gives us the patent that we have provided. The distance is 0.0 because it is comparing with itself. And these are the similar patents that it found. So as you can see, this is on some wireless communication, and all the other patents that I found are also based on some wireless communication links. Let's check out the third option, which is the user ID. So I can provide a pre-saved user here, which is user 1. Provides me with all the patents the user has read. So user 1 has read these 2 patents, and these are the similar patents that it found for the patents read by the user. again sorted by the distance, but this distance is sorted by the similarity. So here the highest similarity will be given preference and it will be shown first. So this system is actually calculating the similarity against all these patents read by the user. In this case, there are 2 patents. So it will fetch the cosine similarity of these 2 patents with all the patents and will give the topmost similar patents to us. So that's it, guys. Thank you. Hope this demo was useful for you and you'll use our patent recommender system. Thanks.